This is a question to calculate equilibrium constant Kp. So we'll need an ICE table for this question. So let me write down the equilibrium equation. So I'll put ICE. I stands for initial, C for change, and E for equilibrium. Now, why did I put A? Because the question didn't give us the initial number of mole of N2O4. So I'll just put an unknown here to represent the number of mole of N2O4. Now, don't worry about putting which unknown because later they'll be cancelled out in this question. So initially, there wasn't any product, so let's put 0 here. Now, if you look at the stoichiometry of this equation, 1 mole of N2O4 will form 2 moles of NO2. If minus X mole of N2O4 happen in this equilibrium, then I'll have plus 2X of NO2 minus X plus 2X. Just follow this stoichiometry. Reactants are being used, so its concentration or its number of mole will decrease. For NO2 is a product, the number of mole will increase. So at equilibrium, I have A minus X number of mole of N2O4. At equilibrium, I have 2X number of mole of NO2. Okay, now the question tells us that this N2O4 is 50% dissociated. That means at equilibrium, I have 0.5 A. Now, A minus X is 0.5 A. That means, I know that X is actually 0.5 A. X is 0.5 A, so at equilibrium, I know that we have a number of mole of NO2 being formed. So this will be number of mole of the reactant and also the products at equilibrium. Okay, now let's write also the Kp expression for this equilibrium because we are supposed to find the value for the Kp. So Kp is partial pressure of the product, PnO2, square, because of 2 here, divided by the partial pressure of the reactant, N2O4. This would be my equilibrium constant expression. Now, before we can calculate a value, I need to find the partial pressure of the reactant and also the product. And I need mole fraction for these two, reactant and product. Now, how to find mole fraction? I need total number of mole at equilibrium, which is 0.5 A plus A. So there'll be 1.5 A. Okay, mole fraction of the product NO2 will be the number of mole of the product, which is A, divided by the total number of mole. So that would be A over 1.5 A. So 1 over 1.5. Now the mole fraction of the reactant will be the number of mole of the reactant at equilibrium divided by the total number of mole. Okay, that would give me a value of 1, sorry, I forgot the A, 1 over 3. Now I have to change this to 2 over 3. After finding the mole fraction, we can find the partial pressure for each of them. Partial pressure is found by mole fraction multiplied by the total pressure. Total pressure is given 1 atmosphere. So partial pressure of the product, nitrogen dioxide, is 2 over 3. Partial pressure of the reactant, dinitrogen tetroxide, will be mole fraction multiplied by the total pressure 1/3. Now with this partial pressure, we will be able to substitute these values into the Kp expression and find a value for the Kp. So Kp will be partial pressure of the product 2/3 square, okay, divided by the partial pressure of the reactant 1/3. So it would be 4/9 multiplied by 3/1. So the answer is 4/3 atmosphere. So the answer to this question is C.